Hello everybody, I'm Mark from MABO Science and I would like to welcome you to our Kali Linux Nmapping, Scanning and Network Mapping tutorial. This tutorial will exist out of three parts. The very first part will be a general introduction regarding TCP ports and some basics on host discovery and network scanning. The second tutorial will handle a more hands-on side of the Nmapping, where we will use Nmapping to see first if it's correctly installed until how to scan a very specific port on a machine. And the third tutorial, that's actually where we're going to use Nmap as you would be as a security auditor or a cyber security officer. So, and here there we will be mainly use the 15 most common commands of Nmap. Now, that's all well. First of all, our little disclaimer. So please be aware that these videos are all tutorials and we really do not encourage anybody to use our courses to start hacking anybody's system, especially now we are entering in a real hacking mode in the sense of using the different tools. So, quick introduction regarding Nmap. So, today, you know that everything is connected to a network and offering services just like printers, routers, web services, IoT even these days, and it has open ports to accept connections to accept those requests. Now, if the correct ports aren't open on a device, it won't function properly. If too many ports are open, the device might be vulnerable to attacks. So, Nmap is one of the most important tools available for cybersecurity professionals, network engineers, system administrators, or security auditors for using Nmap to scan network devices and determine what ports are open so that you can learn what the services they are exposing to the network, verify firewall configuration, or perform tests and troubleshoots as well. Now, once we have discovered Nmap's feature set, you will be ready to run Nmap scans on your own network. So, let's see where we go from here, because what is really required on this course? Now, what's actually required on this course is that it's designed for students who are completely new to Nmap. You don't need any prior experience running network scans or performing cybersecurity assessments. We will walk throughout everything that you need to know, even how to install the Nmap scanner on your system. For that, I do refer yourself back to one of our previous tutorials where we did all that already. Now, you could have a basic familiarity with system administration if you understand the use of IP addresses and network ports. That's a great start, but if not, you will pick along the way. Other topics that closely relate to Nmap scanning is firewall administration. For this course, you don't need to know anything around firewalls deeply, but it would be nice that you would learn it in a later stage, and for that we would recommend you to follow any type of firewall administration essential training. This can be throughout different YouTube channels or actually following a professional course provided by one of your firewall providers. So as you can see, actually it's quite fun to do this course. Now, there is a few items that I would like to talk to you about scanning and the law. Is that Nmap is a network scanning tool and it's also a security tool at the same time, and you really need to be extremely careful when and where you're going to use this to avoid angering other people, even if you would run it on, I would say, a very friendly way. You need to remember that attackers also use these tools, and if you run those tools without permission, it can appear for certain people that you are actually a hacker. Now, the most important principle is that you must remember when deciding whenever you should run an Nmap scan, and that you absolutely have all the necessary permissions before you're gonna run this type of scan on any secured system, and that can be the one where you're working for or of one of your customers. Now, if you're gonna run Nmap on your own internal private network, of course you don't need any permissions. Now, you need to understand as well that certain people do not have a real internal network, and in this sense a private network at home, or that you will not get the permissions from your customer to run Nmap scannings, or even from your own security officers in your organization would say, no, we will not provide you these type of permissions. Now, for that, there is a third part, or a third way out, and that's actually the internet themselves. There are a few websites that are actually specifically built for, let's say, tutorials, and especially for those people who are learning everything around cybersecurity and hacking. Now, one of those websites can be scan.nmap.org or tryhackme.com. Those, for example, are two websites where you may use Nmap for discovering what they have open from network, ports, and so on and so on. So please be aware, if you start using Nmap, that especially when you're going to use it for in somebody's other network, that you have the necessary permissions before you will get in trouble with the law. Now, where we're going to stand with is actually TCP networking. Now, before we're going to start any discussion on how to use Nmap for network scanning, it's important to have a basic understanding on how network functions. Now, let's first talk about the basic networking and the set of protocols known as TCP. Now, TCP is a synonym that stands for Transmission Protocol Control Protocol and Internet Protocol. TCP and IP are the two of the main protocols that make up a modern network. Now, the Internet Protocol is responsible for routing information across networks. The name is literally derived because it's not just on the internet, it's also used on the network in your own home or office or anything else. The main responsibilities of Internet Protocol are providing an addressing scheme known as IP addresses that is unique, identifying computers on a network, and delivers information in chunks better known as packages from their source to their correct destination. IP is what's known as the network layer protocol. It supports other transport protocols that have a higher level responsibilities. The main transport layer protocols are the Transmission Control Protocol, better known as TCP, and the User Datagram Protocol, better known as UDP. Now, TCP is responsible for the majority of the internet traffic. It's a connection-oriented protocol, means it establish a connection between two systems before transmitting data. Now, TCP is also a reliable protocol. It guarantees the delivery of having the destination system acknowledged before receiving any other type of packages. Now, TCP reliability makes it also the most widely used for all applications that require a guaranteed delivery, such as emails, websites, and other IoT devices, databases, whatever you want. Now, because TCP is a connection-oriented protocol, the system goes through a handshake process that's created to connect before transmitting any data, which is known as the handshake. Where are you? Here we go. Now, how does a three-way handshake work? So, very first of all, the client will send to the server a sync, where then the server will send, first of all, an acknowledge, saying from, yes, I did receive your request for sync. Now, before that, it will send at the same time also another sync message, where the client needs to answer, yes, I did resend your sync. And at that moment of time, the transmission can start. Now, all this three-way handshake is based on an actual model which is better known as the Open System Interconnectivity, or OSI model. Now, this model describes networks as having 7 different layers, which is in this case, for example, the physical, the data link, network, transport, and then we have session, presentation, and application. And if you look at here, you're going to see here literally the 7 different layers. Now, if you look between the OSI basic reference model and the TCP model, is that there are actually in the TCP only 4 layers, which is the network interface, the internet, the transportation, and the application. And between you see all the protocols that are used between those different layers. Now, this model describes networks as having 7 different layers. So the very first layer, which is actually the physically layer, which is this one, is responsible for setting bits over the network using wired radio waves, fiber optics, or any other means of communication. Now, the second layer, which is the data link layer, is transmitting the data between the 2 nodes, which means between the client and the server and backwards. So over the same physical network. Now, at that moment of time, we have the third layer, which is actually, in this case, the network layer, and expands the networks over many different nodes. Now, here is where the IP works. So the IP protocol works actually on the network layer. Now, the fourth layer, which is the transport layer, transport layer creates a connection between systems and transfer data in a reliable manner. Now, these are, for example, like in this case, TCP and UDP are actual examples of transport protocols. Now, the fifth layer, which is the session layer, or better known as the managing of exchange of communication between systems. And then we have the sixth layer, which is the presentation layer, which is transferring data from one data to another network and backwards. And then, of course, you have the seventh layer. It's the final application layer, determines which user is interacting with the data using web browser or any other client application. Oops, sorry. So that's all about TCP. Now we're gonna go to IP addressing. Now, IP addressing is actually very simple in the sense of that for the internet protocol to be successful delivering traffic between any 2 systems on a network, it must have an addressing scheme. And it's just like a telephone or phone number or a postal mail use address. Actually, the internet needs also a kind of addressing scheme. Now, because the addresses are used by the Internet Protocol, they are known as IP addresses. Now, in most cases, IP addresses are written in what's known a dotted quad notation, which is, as you can see over here. And it means that you have 4 numbers separated by periods, each number ranging between 0 and 255. Why 255? Because each number is represented using 8 binary bits, and those bits can be presented 2 to the 8 power possible numbers. 2 to the 8 is 256, but because we are starting counting from 0, we can go up until 255 in our IP address value. A system IP address is uniquely identified on a network. If the system is directly connected to the internet, the IP address is used to be not be used by any other system in the world. Now, it's just like your mobile phone number, and nobody else in the world have the same number as you have. So in this case, it's exactly the same. Now, systems that are connected to the private network, such as one in your home or at your office, may use private IP addresses that are reusable in any other networks. Now, your router or firewall takes care of translating those addresses to public IP addresses when you communicate over the internet using a protocol known as address translation, or NAT. Now, don't worry about public and private IP address for the moment. We will come back to them a bit later on. As you can, in a moment, we're gonna go to the other part. Now, there is also another one, which is called the hexadecimal notation, and this one is actually used for the IP6. Why IP6? Now, it's very simple, is that unfortunately IP4 is running out of addresses, and to tackle this, we created a brand new protocol, which is IP version 6, and there are hexadecimal noted. Now, as you can see, an IP address is also divided in classes. Now, we have ranging from class A until class E. As you can see, class A ranges from 1 until 126. Class B ranges from 128 to 191.255. Now, as you can see here, the net ID is actually, which is the internet, and the host ID is your computer if you want. Now, class C ranges from 192 until 223.255.255. Now we have two a bit special ones, which are the class D and E. Is that the D is a multicast address. It's just a very large broadcast over the network, and E for the moment is actually reserved and cannot be used. And by the way, and this is an important note, is that the E range class doesn't have subnet masks, so that's also one of the parts why it's still reserved. Now, IP addresses, we do have a bit of a special range in them. First of all is the 269.254.0.0 until 169.254.0.16. Those are actually known as link local addresses. Now, if you want to know more about that, I invite you to see somebody's tutorial on this, or go to Wikipedia, where it's really well explained. Now, there is another one, and I think you saw that already a few times when you watched or you did a ping on your PC or whatever, is the address 227.0.0 until 227.0.0.8. Those is what we call the loop back addresses, and those are the addresses that are actually local on your own network card. So that's what we call the loopback, and they allow you to validate if your internal network, or better said, your network card is still up and running correctly. And then we have a very specific one, is the 0.0.0.0 until 0.0.0.8, which is used to communicate within your current network. Now, I do recommend you never to use this part, because this is actually, if it's well, or better said, not well set up, you will get in serious trouble. Now, on the other hand, we do have some what we call private IP addresses. Now, those private IP addresses are mainly used internally in an organization, or possibly at your own spot, and that's to avoid that you will communicate very first of all to the internet. So if you would use and you would put your PC, let's say 172.16.0.5, you would never be able to connect and to communicate to internet. Why? For the simple reason it's called a private IP address. So if one of your devices is within this range, it will never be reachable throughout the internet. And at that moment of time, you have to do what we call a NAT, which is a network address translation, which allows you to communicate then at that moment of time with the internet. Now, that's all good and well. Now, let's talk a bit about network ports. Now, network ports are actually very specific, I would say, address points, allowing you to identify which service is running on a device. Now, those that are with network ports around network ports now is that IP addresses may uniquely identify each system on a network, but those systems may be responsible for running many different services, where network protocols come in play. Now, network ports are particularly located on a system associated with a specific application. Imagine that each computer on your network is an apartment building, and each of the applications is an individual apartment. The IP address on the computer is like a street address on the apartment building. Now, but once you arrived at the building, you need specific instruction to get to the right apartment. Now, the network port is likely like the apartment number, guiding traffic to the correct application. Now, network ports are represented using 16-bit binary number, where we write out in decimal form. Now, we have 2 to the 16th power, or 65,536 possible values. Now, just as with an IP address, we start counting from 0, so port numbers are ranging from 0 to 65,535 different ranges of ports that can be used in different ways. Now, ports between 0 and 1023 are known as the well-known ports, which, by the way, is a standard all over the world. Now, these are reserved for common applications and are designed by internet authorities. Using well-known ports ensures that everybody on the internet will know how to find common services on systems such as web services, email services, or any other common used applications. Now, for example, web services use the well-known port 80, while the secured network service uses port 443. Now, ports between 1024 and 49451 are known as registered ports. Now, application vendors may register their applications using these ports. For example, Microsoft reserved the port 1423 for SQL Server database connections, while Oracle registered 1521 for his own databases support. Now, ports above 49,151 are set aside as dynamic ports that the application may use on a temporary basis, where the important port numbers that you need to know are, for example, File Transport Protocol, or better known as FTP, which is 21, or the Secured Shell Protocol, better known as SSH, which uses port 22. Now, as a secured administrator, you need to know, for example, that Remote Desktop Protocol, or better known as RDP, uses port 3389, and that Windows systems uses, for example, port 127, 138, and 139 for network communication using NetBIOS. Now, be aware, NetBIOS is a very old protocol and mainly, or better said, almost not used anymore. However, port 53 for DNS lookup, Simple Mail Protocol, or better known as SMTP, is, for example, port 25. POP3, for example, is port 110. Internet Message Access Protocol, or better known as IMAP, used, for example, by MS Outlook, is using port 153. Now, and then we have, of course, like HTTP, which is port 80. HTTPS is port 423, which is the secured protocol for all this. Now, before scanning all these ports, you really need to know. And if you really are interested to know what are all those ports, I actually invite you to visit a website which is called IANA. This is the website where you register your port number. And this is also where you can find the list of all well-known and all registered ports, which is, if you want to go there, is www.iana.org, and there you can download, if you want, the whole list. And of course, be aware, that's where hackers will look in the first place to see where they can find all the well-known ports. Now, there's one very nice protocol that we like to discuss, and that's ICMP. Now, ICMP is better known as the Internet Control Message Protocol, and it's a housekeeping protocol of the Internet. It performs a variety of important administration functions. For example, one, the most known, is the ping command. Now, it's also one of the most basic network troubleshooting commands that's available for the moment. So when a system sends a ping command over the network, the received system responds with an acknowledge. It's equivalent of one system asking the other, "Are you there? Are you okay?" In addition, the target will respond, "Yes, I am. I am all through." Instead of speaking these or providing those questions with an answer in English, now the ping command uses the ICMP protocol. The "Are you okay?" question is asked by sending a package known as an ICMP echo request. Now, the target system responds with, "Yeah, I'm fine, I'm here," and it will actually send an ICMP echo reply command. Now, if you want to know how this works, let's see what we can do if we do a quick ping command to a system. So let's switch systems. Here, let's log in. We're gonna open up the terminal. Let's say ping google.com. Now what happens? Here you see it's actually replying back saying, "Yes, I'm fine." Now I just do a Ctrl+C to stop the ping. So first of all, what do we see? So 8 packets were transmitted, 8 packets were received, 0 packages were lost, and the actual time was 7,140 milliseconds from getting the reply back. Means from sending from my system to Google and back took 7,014 milliseconds in average. Now, if you can see here, you will see that it's actually sending out 56 bytes of data, and that each reply takes about 84, 19, 16, 21, 17, 16, 21, 18, and another 18 milliseconds to get everything back and forward. So this is already one of the examples regarding ICMP. Now what you can do as well is actually tracking, or better known, trying to do what we called a traceroute. Now, if you would do a traceroute, at that moment of time, you will start trying to hop. Now, I performed already in the previous session a traceroute because it can take a while. And what I did is I took a traceroute to tryhackme.com. Now, Traceroute by definition will try over 30 hops. So if it's more than 30 hops, it will reply or stop the system and say, I'm sorry, I can't go any further. Now, for my system, which is a local address, it goes first to telenet.be, which is one of my internet providers. Then we go to arata.net, which is a Belgium entry point. Goes again here. This is actually a backbone located in the Netherlands. Then we go to Talinet, and then you see here request a timeout. That means it did try to go to a certain road, and actually it blocked. So it tried another entry at Talinet. We got a few blocked sites, means it did not reply actually to our traceroute. Now be aware, if you get this, it doesn't mean necessarily that the system is down. It just can be that it is blocking our ICMP message as well. And then suddenly it pops up and we are at tryhackme.com. So, and actually this is how Traceroute works, and you can actually see how the communication goes from your place until a certain website or any other system, because it can be, of course, used by any other system. Now, this is already good news, because now we can actually start using Nmap. So before we're going to use that, I would give you here all the answers that ICMP message can give you back. Now, this is just here for, I would say, information purpose. If you want, you can actually go and grasp all the ICMP sources and see what all types are there. Here you're going to see about 10 messages, but actually there are way more. For those who want to go, I would say go to Wikipedia, for example, or go and use the ICMP source to see what's all out there. And I can tell you, it can be very interesting for those who like to go to the nitty-gritty detail. Because here you're going to see, for example, ICMP type 3, which is actually another one for IP for version 6, is the echo lie. Is the destination not unreachable, direct message, extra message, and so on and so on. So for those who want, it's all here. Have a look on Wikipedia. Go and see the ICMP message, which is actually also a well-known protocol, to see what's all out there. Now, as I said here, the ICMP, the traceroute. So very first of all, the very first hop as we did, we go to 1. If that doesn't work, we go to the second one, to the third one, the fourth one, and so on, until we reach our target server, and then we get our final ICMP message back. Now, be aware, if you would like to try, for example, from home, and you would like to do a traceroute of, let's say, the PC you're working at your work, I can guarantee you 99.9%, I'm quite sure you will not be able to do a traceroute to that. Now, on the other hand, if you would try to do a traceroute of the web server that your organization is using or your company, yes, you will get a result, but be aware, it's not necessarily the address that you expected, because very often the internal addresses and the external addresses are completely different, as explained before, because for the simple reason network administrators will avoid that any ICMP messages will be replied from the outworld, or what they will do is they will do some what we call network address mapping, so that actually the internal addresses are actually completely outside the system. Now that all set, we go to our Nmap himself. Now for host discovery, as you can see, we can do a -SL, -SN, and so on and so on. Now here, these are a lot of them. Now actually one of them which is the most used, and let's go to a few of them, and I will switch back to my other system. Let's clear this system. Here we go. Is that we actually, what we're going to do, for example, is Nmap scan.nmap.org. Now, if I do this, it will become very, very slow. Why? For the simple reason is that when you do this, there is a kind of, how should I say, level of scanning. And in this part, the level of scanning is level 3, and it's actually quite slow. Now, if you want to speed that a bit up, I give you already now a kind of a heads up. Try to do just a -T4, which actually will speed up the system. Now, from where I'm located, unfortunately, Scan Me, Try to Hack Me, and a few other IS systems are quite far away, so unfortunately the reply will become a bit on a delay. Now let's hope this is going fast. And here we go. Oh, it says cannot still resolve. Let's try .com. Can be that it's .com that I by accident got myself in a kink. Okay, so as you can see here, it has 3 ports open. Now we can try another one, which is the Try to Hack Me, and it's like Nmap -T4 tryhackme.com and Nmap. Okay, and here we have a few other ones. And as you can see, now these are by definition the open ports. Now I can tell you already there are way many more ports open, but this is of course for our next tutorial, where we will of course gonna go more in depth to see which actual ports are more available. As you can see, there are about 979 ports that are filtered, so demonstrating there is much more behind the scenes. Now, so if we now go back, there are way more, of course, possibilities. Now I cannot go in, I would say, in full detail in every single, I would say, possibility, but one which is a really nice one is the Traceroute. Now I would invite you to go to your own system, try to go to tryhackme.com and using the -- Traceroute possibility, and you will see that there is some very nice possibility. As you can see here, I did a -pn, for example, and you see a lot more things available. Unfortunately, I did not copy the result of the Traceroute results, but I will add that into the comments, and you will see it's a quite nice and neat one. Now, for network scanning, on the other hand, it's actually plus minus the same, and that's where we're gonna do the discovery of all the different networks. Now, here I would suggest to use these two to see what's going on, and that's what we're gonna do now on our system. So let's go back to our VM. Let's clear this, and let's do an Nmap -t4 -pn try hackme.com -su. And as you can see now, it says go and bugger off. For the simple reason you don't have root privileges. This is very normal for Nmap. Once you start doing in-depth network scanning, it does require root access. So to go there, you need to do a sudo -i, type in my password, and bring back the comments or the commands. And now we are able to execute. So when you're using Nmap, once you start to be working really in detail with it, you will notice that it does require a lot of the, I would say, root access. That's strange. Seems that I changed the bits. is that they do not have anything open for the moment. On UDP, that's very, very strange. Means they have changed a few of their items as well. Now, that's not a problem. Let's go for another one, and we're gonna do actually a minus SS. This is not as you think. This is actually to say we're gonna now do a TCP scan, and we're gonna scan on a sync flag, see what's going on. Let's see what we get back. So, okay, now we saw everything. What I would suggest is that you join us for our second part on Nmap, which will be a more hands-on tutorial. And if you liked it, please give the thumbs up. If not, give the thumbs down. And if you would like to be kept in the loop on what's coming out, please subscribe. And I hope to see you all back next time. And thank you very much for watching. Bye bye.